Good afternoon, students. So far in last class, we have completed the data quality and what are the tasks in data pre-processing. These are the concepts we have to discuss in last class, and in detail of what are the tasks we have to use, what are the tasks of the data pre-processing, that is the data cleaning, data integration, data reduction, and data transformation, and data discretization. So these are the tasks mainly we have to perform on data pre-processing. So already in last class we have to completed the data cleaning. So here we have the data cleaning. How the data you have to clean. So what type of problems will be raised? What type of data you must be cleaned? So here we can represent that is the incomplete data, noisy data, inconsistent, and intentional data. This type of data you have to clean by using the various methods. So here data, how to this missing data you have to how to handle. These all things we have to discuss in last class. Ignore the tuple, filling the missing value manually, fill in automatically with unknown value, that is the global constant value. And what is the noisy data? Noisy data is a random variable or variance in measured variable. Noisy data means actually the value is in the minimum value is 5,000. For example, you have to take the employee salary. Minimum salary is 5,000. So the values must be in that range only, but you have to enter the -10 or 5 lakhs. Or you have to enter the unknown values. That is not in the bound. That is the not in the bound. So that type of values you have to call it as noise data. So those type of data you have to remove by using this binning process, regression, and clustering, and combined computer and human inspection. So by using these methods, you can handle those type of noise data. This is regarding to this how to handle the noisy data. So by using these methods, you can handle the noise data. So data cleaning is simply, you can say that it is a simple process. It is data discrepancy detection, checking the field overloading and using the metadata, checking the uniqueness rules. For example, you have to take the particular data set. So all employees information based on that employee IDs only. Okay. Employee IDs, whenever you have to define the employee IDs, that employee must be unique in that organization. That is the uniqueness rule. So you must be follow whenever the data set you have to define, you must be follow that rule. It is the uniqueness rule, consecutive rules. So number wise also consecutive numbers we have to given for the particular department. So null rules. These are the data discrepancy detections we have to process in data cleaning. What are the commercial tools we have to use in data cleaning? That is the data scrubbing and data auditing. So here you can use the simple domain knowledge like to detect the errors and make corrections. Like postal codes, spell checks, can all handle this type of data by using the commercial tools. Next one is the data auditing. So in the data auditing, generally analyze the data to discover the rules and relationship to detect the violators. Correlation and correlation and clustering. So correlation and clustering to find the outliers. So outbound values mainly we have to you can identify with this data auditing, and uniqueness rules. All you have to the data you have to audit by using these commercial tools. This is regarding to the data discrepancy detection. And the next one is the data migration and integration. So you have to combine the data by using the data migration tools. Mainly these tools are allows transformation to be specified. What are the tools you have to use it for the extraction and transformation and loading? That type of tools are called ETL tools. ETL tools. By using these tools, you have to extract the data from a given data set and transform the data. Transform the data, that means in the form of salaries you have to give in, uh, uh, transforming the data one organization to another organization, as well as loading the data from that means accessing the data from the database set. These type of operations you have to perform. These type of operations you have to perform with the CETL tools only. So allows the user to specify the transformations through the GUI, graphical user interface. Okay, this is regarding to the data cleaning. Already in last class we have to complete it. Now in today's class we have to discuss with that data integration. So here in the data integration also you have to discuss. So in the data integration mainly you have to combining the various data sources, that is simply you can call it as data integration. So here entity identification problem, detecting the resolving the data value conflicts. So here a particular data, for example, you have to consider the particular customer there in a particular bank. That customer have the accounts in different banks. So information is same, but the name only, the customer ID only you have to different. So that is the way all the people in various banks we have the in various branches we have the number of records are there. So those records we have to combine with this common information. That is the entity identification problem we can do with this data integration. So here you can data handling the redundancy in data integration. Redundant data you can often when integration of multiple data spaces. First one is the object identification. Who are the customer ID you have to represent. And it's the derivable data. That means it's the common information. The same attribute or object may be different names and different databases. For example, I want to open a particular account, some name and surname. So name and after surname. So next one, I want to open the another account in another bank. That is the surname is first and full name is next. So that is some minor changing the names. You can create the number of accounts. So that is the object identification first, and it's a derivable data. One attribute may be derived attribute in another table. That is the annual revenue. So here you have to represent that is the redundant of attributes may be able to detect by correlation analysis and covariance analysis. Generally here you can use that in our programming for these attributes, that is the COR function, and covariance analysis for the, you have to use the COV function. So here now you can discuss with the nominal data of the correlation analysis. So here, whenever you want to perform the particular test in correlation analysis in between the two variables, by using the formula, that is the x square is summation of observed minus expected whole square by expected. So by using this formula, that is the chi-square test, simply call it as chi-square test. So with this chi-square test, you can find out the value. The larger of the x value is more likely to be the variables are related. See here, for example, you have to take an example for the chi-square calculation. Like science friction is play chess, that is the 250, and not play chess, that is the 200, and their sum is 450. 250 plus 200 is 450. So like science friction, you have to represent it as sum of play chess or play or not play chess, we have to represent it as 450. Like size friction, we have to represent. Not like science friction, that is the play chess is 50% and not play people are 1000. That is the 1050, their sum. So summation of play chess, only 300 people only play the chess. And not play chess, you have to 1200 people are there. So their sum is 1500. You can say that this is the one table you have to represent it like regarding to the like science fiction and not like science fiction. Who are the playing or not playing. So now we have to calculate the chi-square test for this given data. Chi-square calculation, numbers in parentheses are expected. Counts calculated based on the data distribution in two categories. First one, this is the rows, that is x square, that is chi-square, we have to call it as chi-square. First one, expected minus, already we have to just now, that is the observed minus expected. This is the observed. So what we have to observe in playing the chess, only that people are 250 and not observed, that is expected is actually 90, we have to assume, but observed as a 250. So now we have to find out the chi-square value, that is the 250 minus 90 whole square divided by expected, that is the 9. Similar way, 50, you can find out the not like science fiction value, that is the summation of like science fiction value, you have to find out here. And now we have to find out the play chess with the not like science fiction. 50, that is the observed, and 210 is the expected. So 50 minus 250 whole square divided by 210. Similar way, like science fiction for the not play chess, that is the observed is 200 and expected is 360. So 200 minus 360, that is the observed minus expected. 200 minus 360 whole square by 360 expected, that is a 360. Similar way, not play chess with the not like science fiction, that is observed is 1000 and expected is 840. So that is 1000 minus 840 whole square by expected, that is the 840. So now you can minimize these values. So regarding to this play chess and not play chess with the like science fiction and not like science fictions. So you get the value 507.93. This is the chi-square value. We have to testing the value, that is it shows that science fiction of the play chess are correlated. This is the relationship. So here correlation coefficient, or is also called as Pearson's product product moment coefficients. So row of correlation coefficient we have to find out, that is the row of AB equal to summation of I to 1 to n A of I minus A bar and B of I minus B bar by n minus 1 row A and row B. So we have to find out these values. With these values, we can positively correlated or negatively correlated, we have to represent it. Whereas positive correlated, that represented as stronger correlation between the variables, and 0, that means AB, that is the correlation coefficient is equal, A of B equal to 0, that is the independent values. And here where the positive values. So for example, here you have to consider that correlation coefficient where the coefficient value is positive, that is simply it is a stronger correlation between those variables. Where the values is R of A of 0 is 0, that is the independent, A is independent, similarly B is also independent. And whereas then R of AB coefficient, that is the correlation coefficient value is less than 0. Less than 0 means that is a negatively correlated value, positive correlation, independent, and negative correlation. So we can process this correlation coefficients in correlation analysis on numeric data. So see this diagram shows scatter plots of various visually evaluating the correlations between the variables, that is the -1 to +n. See this plots. So the values are, these all our points are related to the data points. So what are the points you have to represent it as? All our data points. All you have to show on scatter plots in between the -1 to +1. Okay. So here correlation viewed as a linear relationship can represent the correlation measures the linear relationship between the objects. For example, we have to consider in a particular data set, you have the number of attributes. In those attributes, the relationship between the one attribute to another attribute, you can find out with this correlation analysis only. So correlation between the correlation measures the linear relationship between the objects. Or you can say that it is the attributes. You can represent the relationship between the attributes also. You can you can find out with the correlation only. So to compute the correlation, we standardize data objects A and B and take their dot product. So for example, we have to consider the standardized data objects like A and B. We can find out the dot product value, the correlation between the A and B, that is the A inverse into, that is the dot product of B inverse. So A inverse of K equal to AK mean of A by standard deviation of A. And similar way, B inverse of K, we have to find out BK minus mean of B by standard deviation of B. So by using these formulas, we can find out the correlation in between the variables. So here I can find out the covariance value. So covariance value in between the variables, we can find out that is the A of covariance of A comma B is equal to E of A comma A inverse B comma, that is the B minus B inverse. So this is the value by using this formula, you can find out the covariance value. It is similar to the correlation one. So we can find out the relationship between the correlation and covariance. How we can find out? Here we can represent the R of AB, that is the correlation coefficient, is equal to covariance of A comma B by rho of A into rho of B. By using this formula, you can find out the relationship between the correlation and covariance. So where n is the number of tuples, we can represent it. A inverse and B inverse are the respective means or expected values of A and B. Rho of A and rho of B are the respective standard deviations of A and B. So if the covariance of AB value is greater than 0, similar way in correlation, where the positive values are there, that values are simply called it as positive covariance. Where the negative values are there, that is simply called it as negative covariance. And where the value is 0, that is the converse is not true, that is the independence. Okay, almost all covariance and correlation are similar, but the formulas are different. Covariance of AB, that is the E of A comma A minus A inverse, B minus B comma B minus B inverse, that is equal to a summation of I equal to 1 to n A of I minus A inverse B of I minus B inverse by divided by n. This is the way we can find out the covariance between the two variables A and B. So easily you can simplify this equation. Covariance of A comma B equal to E of A in A dot B minus A bar B, A bar and B bar. So by using this formula, we can easily have to compute the covariance values, covariance between the two variables, that is the A and B. For example, you have to say suppose two stocks A and B having the following values in one bit. So first day, A stock is 2 and B stock is 5. And second day, A stock is 3 and B stock A stock is 5 and B stock is 10. And fourth day, A stock is 4 and B stock is 11. And fifth day, A stock is 6 and B stock is 4. So now you can find out the values between the covariance in between these variables, that is the stocks A and B. E of A, that means we can find out the average. So 2 plus 3 plus 5. So this is the 2 plus 2 plus 3 and 5, 4, 6. So that is the mean. You have to find out 1, 2, 3, 4, 5. So 2 plus 3 plus 5 plus 4 plus 6 divided by 5. You get the 20 by 5. You get the value, that is the 4. So similar way, E of B, 5 plus, that is the 5, 8, 10, 11, and 40. So divided by 5, you get the value, that is the 9.6. So now you can find out the covariance between the variables, that is the E of A dot B minus A inverse and B inverse. So covariance of A and B, you can find out 2 into 5. So these two values, 2 into 5, 3 into 8 plus 5 into 10, 4 into 11, 6 into 40, divided by 5 minus divided by 5 minus 4 into A bar and B bar. Now you can find out the A bar and B bar value. 4 into 9.6. So this is the 4. This is the value 4 into 9.6. You get the value. After minimize the value, you can get the 4. So A and B rise together since covariance is greater than 0. That is the positive. So this is regarding to that data integration. And next one is the data reduction. So in this data reduction process, whatever the data you have, the entire data, for example, a particular data set or particular table you have to consider. In that table, you have the nearly 1,000 or 2,000 records are there. So how you can minimize that data? How you can minimize that table by using this data reduction on. So here you can use the 3 types of reductions. First one is the dimensionality reduction. Second one is the numericity reduction. And third one is the data compression. So here, data reduction. Data reduction obtains the reduced representation of the data set that is much smaller in volume, but it produces the same analytical results. So here you want to reduce the data. You have the use data in the data set. From that data set, you want to reduce by using this data reduction. So this data reduction, for example, you have to consider a database or data warehouse may store terabytes of data. So complex data analysis may take very long time to run on the complete data set. So data reduction strategies, mainly you have to use the 3 types of reduction strategies we have used in data reduction. First one is the dimensionality reduction. Second one is the numericity reduction. And third one is the data compression. First one is the data dimensionality reduction. In the dimensionality reduction, we have the remove the unimportant attributes. So you have the in a particular data set, you have the 15 attributes are there, but only few attributes, only 5 attributes are only you have to use. So what about the remaining 10 attributes? So those attributes you have to remove in the dimensionality reduction technique. Remove the unimportant attributes. So here you can use the 3 methods. One is the Wavelet Transform. Second one is the principal components analysis. And third one is the feature subset selection and feature creation. So by using these 3 methods, you can reduce the data in dimensionality reduction. And the next one is the numericity reduction. In the numericity reduction, some of the apply call it as data reduction. So here you can represent the regression and the log linear models. So whenever the log linear models you have to use numericity reduction, whatever the data you have, the data you have to represent it in graphical form and the relationship between the attributes. That is the regressions and log linear models, histograms, clustering, sampling, data cube aggregation. So these are all type of techniques you have to use in numericity reduction. And the last one is the data compression. Data compression means you have to minimize the data. This type of reduction strategies you have to use in data reduction. So in the data reduction, mainly you have the first one is the data preprocessing. You have the 4 tasks are there in data preprocessing. First one is the data cleaning. Second one is the data integration. And third one is the data reduction. And fourth one is the data transformation and discretization. See here, data reduction, how we can reduce the data. Dimensionality reduction, first case, curse of the dimensionality. Curse of the dimensionality. When the dimensionality increases, data becomes increasing sparse matrix. Density and distance between the points, which is critical to clustering, outlier analysis, become less meaningful. The possible combinations of subspaces will grow exponentially. So avoid the curse of the dimension, that is the dimensionality reduction, and help the eliminate the irrelevant features and reduce the noise. And third one is the reduce time and space required data mining. And the fourth one is the allow easier visualization. So these are the dimensionality reduction. And what are the techniques we have to use in dimensionality reduction? So mainly here you have to use the three types of reduction techniques you have to use. First one is the Wavelet transforms, and third one is the principal component analysis, supervised and nonlinear techniques. So this is the diagram which shows mapping data to the new space. Fourier transforms and Wavelet transforms you have to use. 2 sine waves and 2 sine waves plus noise. So finally you can get the frequency. Decomposes the signal on different frequency subbands applicable to the n-dimensional signals. Data are transformed to preserve relative distance between the objects and different levels of resolution, and allow natural clusters to become more distinguishable, used for the image compression. See here, this is the Wavelet transform. All the natural clusters to become more distinguishable. So see here, this is the Wavelet transform. That is the discrete Wavelet transform is a linear signal processing, multi-resolution analysis. Similar way here, we have to take the wavelets. That is the math tool of the space efficient hierarchical decomposition of functions. S equal to 220, 235, 44 can be transformed into the S 2, 3 by 4 minus 1 whole power 1 minus 1 1 by 4 comma 1 by 2 comma 0 0 minus 1 and minus 1 0. So these are the values regarding to the Wavelet decomposition, compression the data. Many small detail coefficients can be replaced by zeros, and the only significant coefficients are retained. These are the Haar Wavelet transform. It uses the hat-shaped filters and effective removal of the outliers, multi-dimension, multi-resolution, and efficient and applicably to low-dimensional data. So here, we have to represent the principal component analysis, that is the PCA. Find a projection that captures the largest amount of variation in data. The original data is projected on a much smaller space, resulting dimensionality reduction. We find the eigenvectors of the covariance matrix. These eigenvectors define the new space. So finally, analysis is greater less than 1, less than k is less than or equal to n. orthogonal vectors, and you have to represent it, that data. So in next class, we'll continue this log linear models, regression analysis. Then after, once you have to completed this one, then we'll start the next method, that is the directive aggregation.